Okay, good morning, Lexi. I wanted to go over the proofs and provide those to you for lesson 68. So when you are up and ready to roll, you can follow along. So the first proof is number 23. This is to lesson 68. And we have a triangle here that is named ACE. And it has perpendicular lines, it says, being drawn from here to here is LV, and another perpendicular line from here to here, which is RZ. We know if there's perpendicular lines, we know what that means. That means that creates right angles. Now let me write the given information up here though, because we want to be able to know what we're placing into our picture here, what we're trying to prove. So AC is congruent to CE. So I'm going to go mark that. AC. Okay, so that's the two big legs on the big triangle. So let's just take this blue highlighter and mark those congruent to each other. Okay. The next piece of given information is what I already have done, which is RZ is perpendicular to AE. And LV is perpendicular to AE. And I actually knew that ahead of time. So when I said that, when I was drawing those in there, I said they were perpendicular because I knew that that was given information. I did not just assume it when I was drawing it. So let's make sure we know that. Remember, I said in geometry, it's not safe to assume anything. Everything has to be proven. Okay, but in the end here, what we're trying to do with all this given information on this diagram is to prove triangle RZE. So I'm going to go mark that. Actually, what I'm going to do is color it in. RZE, which is this little guy right here. We're going to prove that that triangle is similar. That's what this little doohickey means right here. That little squiggly line means similar to LVA. So that is this one right here, LVA. Okay, so we're trying to prove those two yellow triangles to be similar triangles. And remember that in order to do that, all that we need to do is prove that two angles in each of those triangles are congruent. So we have two corresponding angles congruent to each other. Once we have done that, then we can say these are similar triangles. Okay, so far, because of these two perpendicular lines coming down here that I'm drawing a little bit heavier so you can see where I'm at, and this line here, we were told in the given information, those are perpendicular lines. Remember, the symbol alone for perpendicular lines up here is an indicator of what a perpendicular line does. What does that mean? It intersects to create right angles. So we're going to just mark these ones inside those triangles as right angles because that's all we're really focusing on are those two triangles. In other words, it's not really necessary to draw them out here, even though those are also right angles. We only really need to focus on the ones inside the triangles, since that's what we're trying to prove similar. Okay, so far we have two sides congruent, but it's the longer sides. But remember what that means. That means this is what kind of a triangle? It's an isosceles triangle because of these two congruent sides. And remember, in an isosceles triangle, if the two legs are congruent, then the base angles are also congruent. So we know that we have those two angles that are congruent to each other as well. Well, look at there. What did we say over here? We said all we have to prove is that we have two sets of corresponding angles that are congruent to each other, which we have. Angle A and angle E are congruent. And then the ones where here at angle V, which is actually angle AVL right here, and angle RZE are congruent. So we have our two angles proven, corresponding angles in those triangles, and that's all we need to prove that those are actually similar. So let's go ahead and get this into a formal proof table. So we have statements and we have reasons, and we've already talked through it so we know where we're heading. So the first thing you're going to see is that they should, I'm not sure in your program which is blank and what they're asking for, but we're going to start out by giving this given information because that's important. All of it's important, but we want to list that we have this given information because that helps us to know that the sides are congruent, so the base angles are congruent. And because of that, we're going to say that. So angle A and angle E are congruent because why? Because of the base angles theorem. Number 3, we need a little bit more given information because we've exhausted what we can do with the step number 1 information that was given to us. We figured out the base angles are congruent, but now we need some more information about this shape. So we're going to mark down RZ is perpendicular to AE and LV is perpendicular to AE. And that was simply given information. And because of it, we know if they're perpendicular, they have created right angles. So we're going to write down here the right angles that were created. And we said it was at RZE. That's this one right over here. Let me kind of color it in pink. RZE. And then I'm going to make mention of this one over here at LVA. So RZE and LVA are right angles. I'm going to abbreviate angles there. And why? Because perpendicular lines, I'm going to put the symbol in there, intersect to form right angles. Okay? And based on the fact that those are both right angles in each one of those triangles, we want to make mention of them being congruent because we need to show congruency. Oops, that should be an angle there. There we go, angle RZE. So we're kind of repeating step 4, but except now we want to actually state that those angles are actually congruent to each other. And why? Because all right angles are congruent. Right? They're all 90 degrees. So we have to make that statement because these are our 2 steps right here. We have shown that those angles are congruent and those angles are congruent. And that's all we need to prove those 2 triangles are actually similar. So we're going to make that final statement that RZE is similar to LVA. And we use this reason, angle similarity. Okay, and that is proof number 23 from lesson 68. I'm going to go ahead and continue on the same blank sheet of paper, and in this same video, we're going to do number 24. That way you'll have them both right here. So let's just start right here. Number 24. Let me draw this shape. So we have this triangle. Looks like this. And we have RPD. That is the big triangle. And in the mix of that, we have what looks like an X in here that actually we're told are altitude. So we have to remember what an altitude does. Remember, an altitude, the other word for altitude is simply the height. I'm going to go ahead and mark these as S, L, and E. Now here's our shape. So let's put the given information down here. So here's what we're told. Triangle PRD, that's basically just making mention of the shape that we're looking at with altitudes. Basically, lines that are showing the height of the triangle LD. With altitudes LD and PS, that is showing the height of that triangle from 2 different vertices. Okay, because if you look at LD, it starts up here and runs down. If you look at PS, it starts at this vertex at P and runs down. Okay, so we have 2 altitudes. And remember, when you show that, let me just draw something out here. I'm going to erase it in a minute. But remember, anytime you go from a vertex and you draw an altitude, you're drawing the height of that triangle. And it always creates a right angle because it's standing straight up and down. It's not leaning at all. Okay, so we can use that information. Let's go ahead and get our statements and reasons table down here. Statements and reasons. so we're going to start off by some of the things we've already discussed. We stated that we have this triangle called PRD who has, I'm going to put this little with symbol, who has altitudes, and their names are LD and PS. Okay, and that is just simply given info. So we'll write that down as such. Let's see if I can make this just a little bit bigger for us. There we go. Okay, and because we have altitudes, we know that when they hit that side opposite the vertex that they're starting from, so in this case with P going down and meeting there at S, because it's an altitude, it created a right angle, and the same would be true for this angle. Oh, by the way, what are we trying to prove here? I suppose it would be helpful if I wrote in there what we're trying to prove. I'm going to bump back up here for just a minute. We're trying to prove triangle LEP is similar to triangle SED. So I'm going to go highlight those in yellow so we can look at those two triangles. So LEP, this one right here, LEP. Trying to prove that that is similar to SED. So this is going to work out really nicely, you're going to see. Remember, the same is true. We have to prove two angles in those triangles congruent, two pairs of corresponding angles proven to be congruent, because once we've done that, then we can use the angle-angle similarity. And so far, we've already succeeded at showing that the right angles are congruent in both of those triangles. So let's go ahead and write what those altitudes did for us. So LD is perpendicular, so we're going to write this out to PR. And so LD is perpendicular to PR, that's correct. And then PS, which is the other altitude, is perpendicular to the other side over there, RD. And that's just the definition of an altitude. So we took the information that, oh, wait a minute. We took the information, altitude, I can't spell. We took the information that was given about the altitudes and developed it into stating that the altitudes, because that didn't tell us in the given information, we just know their altitudes. So we have to know how to navigate and use those as valid information. So we state that they're perpendicular lines. That helps us to then get to the next step. Perpendicular lines create right angles. So we're going to state that angle PLD and angle PSD are right angles. Okay, we've already marked them. I'm just naming them now. And we say perpendicular lines, so I'm going to use that little symbol there. Perpendicular lines intersect. We actually said this earlier, I believe. Intersect to form right angles. Number 4. Let's see here. Anything else you can identify in those triangles that are congruent? Hopefully you've already seen it. Hopefully you're just over there screaming up and down saying, don't you see it, Mrs. Quigley? Because yes, I do. Remember when I always cross my arms, I always say, this is what vertical angles look like. What do? They create congruent angles at the where the vertex meets, where they crisscross. We've now created vertical angles. But wait 1 second. I got to bump back a minute. That's going to be step number 5, because in number 3, I just stated that those two angles are right angles, but now, just like in the last proof, I need to state that that makes them congruent. So on step 4, for the reasons, because all right angles are congruent. Now let's go to 5. We'll say those vertical angles are congruent, so let's write that in. So angle LEP is congruent to angle SED. And why? Because pairs of vertical angles are congruent. I'm doing a lot of abbreviating here. I hope that you're able to make out what I'm saying. I'm speaking it as I write it. And then finally, let's see what we have. Do we have enough to prove this? So we said we have number 4 shows congruent angles and the two corresponding angles congruent in the two triangles. And also step number 5. So there's our two angles, two pairs of corresponding angles are congruent, and that's all we need to prove that LEP, the triangle LEP, is similar, not congruent, similar to, and we know they're congruent too, but they're similar because if you look at the shape, one is smaller than the other. So truly they're not congruent because their sides are not congruent, right? But in order for them to be similar, remember we talked about that whole scale Ella thing? I'm going to send you that video so you can watch it because I keep talking about it and you have no idea what I'm talking about. But when you watch that, you're going to see that when you scale things up and down, everything kind of forms according to how many times larger it's getting or how many times smaller it's getting. But the cool thing is in a triangle, the sides are the only things changing. The angles all stay the same. So if we can prove two angles congruent in two different sized triangles, we can say they're similar, which means they've scaled down in a proper way. So angle, similarity, I think I spelled it wrong. There we go. Similarity, and that's how we prove that in number 4's proof. Okay, I'm going to send these on.